Okay, so for section 3.5, we're going to start talking about rational functions and their graphs, okay? And rational is just our math phrase for fraction, okay? So to set up, we have these are the form P of x over Q of x. We do have to have an x in the denominator. Now, we also have the stipulation that Q of x cannot equal 0, okay? And that keeps us away from our division by 0. Now, we do need to discuss domain issues, and we've discussed these one time before when we talked about combining functions and composition of functions, that we needed to watch out for things to keep out of the domains for when we're combining functions. So now, looking at them on their own, the domain issues are still going to happen when our denominator equals 0. So we're going to look at a couple different examples here, okay? And we're going to look at them just as they sit, okay? We're not going to do anything special with them, anything like that. So the first one that we're going to look at, we've got x squared minus 25 over x minus 5. And so if we're going with this concept, x minus 5 cannot equal 0. I'll add the 5. So x can't be 5. There's our domain. Now, this is a perfectly acceptable response for a domain. This implies that x can be anything else that it wants to be besides 5. Okay, that's the only one that's off limits. If they ask for this in interval notation, it would look like this. Okay, so if it was asking for interval notation, it would look like this. Now, next example. Okay, so following our same logic, x squared minus 25 can't be 0. I'm going to add 25. So I've got x squared can't be 25. I'm going to need to take square root on both sides. And remember, if we bring in the square root, then we're also going to need to bring in the plus and the minus. So x can't be plus or minus 5. Sometimes you will see this done as x can't be negative 5 or positive 5. They'll just list them. If we were going to talk about interval notation, we would have negative infinity to negative 5, unioned with negative 5 to 5, unioned with 5 to infinity. Okay, so we'd have one that looks like that. Again, kind of every place we see a union, that's where we're kicking out a value or a number. Okay, so let's look at one more that you may come across or similar to. Now, sometimes you might have to factor the bottom. Okay, and if that's the case, then you just set each piece can't equal to 0. Now, with this one, kind of following our same concept, we're at x squared plus 25 can't equal 0. I'll subtract that 25. Take my square root. Now, here, square root of 25 is still going to be plus or minus, but it's square root of a negative, which means it's I. Now, these are complex. We will not deal in the complex world unless we have to, okay? So this means that there's nothing in the reals, okay, in real numbers that we're getting rid of. So my domain would be all real numbers, which would be represented by the double scripted R. They may just write it out, all reals. Interval notation, it would run negative infinity to infinity, okay? So we only have to worry about those.